Before you can trust your analysis, you first have to trust your data. That's why every analytics project starts with data profiling and data cleaning. In this video, I'll show you exactly how I approach both using a real e-commerce dataset in Postgres. Let's begin by profiling the data. Before making any changes, I want to understand whether this table actually contains any issues. I'll start by looking at the order items table. This table contains every product purchased in every order, including the product ID, seller ID, price, shipping cost, and shipping deadline. Before running any validation check, it's always a good idea to inspect the raw data and understand what each column represents. One of the first business rules I want to validate is whether any products have a negative price. From a business perspective, selling a product for a negative amount doesn't make sense because it would affect revenue calculations and could indicate an issue during data collection or import. That's why this query checks whether any prices are below zero. Fortunately, the result is zero. That means no products were sold for a negative amount, which is exactly what we expected. Next, I want to know whether there are any products with a price of exactly zero. Unlike negative prices, zero price products aren't necessarily incorrect. Some businesses offer promotional items or giveaways. So instead of assuming there are errors, I simply count them first. If any exist, they can be investigated further before deciding whether any action is needed. This is a good example of why analysts investigate first instead of immediately modifying the data. Now I'll validate the shipping cost. Freight values represent the cost of delivering a product to the customer. Since shipping can't realistically cost less than zero, any negative freight values would immediately indicate a data quality issue. Running these checks help confirm whether the shipping information can be trusted before moving on to analysis. Again, the result shows zero negative freight values, which tells us the shipping costs are valid. If you are enjoying this walkthrough and want to learn more about Postgres, SQL, and data analytics through real projects, consider subscribing to the channel. I post practical tutorials like this every week. Now let's move on to the data cleaning stage. Now that we've validated the data, it's time to start cleaning it. I'll begin with one of the simplest examples, standardizing product category names. The first step is creating a new table called Product Category Translation Clean. Rather than building it from scratch, I'm selecting the existing data from the staging table and storing it in the analytics schema. This gives me a safe place to make improvements without changing the raw data. During profiling, I discovered that a few category names contained spelling mistakes. Even though there were only a handful of records, inconsistent names can split your reports into separate categories and produce misleading results. Here I'm updating those values so every category follows the same naming convention. Finally, I ran a verification query to make sure the updates were applied successfully. Verification is an essential step in any cleaning workflow because every transformation should be confirmed before the data is used for analysis. The corrected category names now appear exactly as expected, confirming that the cleaning process worked successfully. So far, we've corrected inconsistent values. The next table presents a different challenge, handling missing information while preserving the original meaning of the data. I'm going to create a new table called Reviews Clean inside the analytics schema. Just like before, I'm leaving the original staging table untouched. This gives us a clean version for reporting while preserving the raw data exactly as it was imported. As I build this table, the first function I'm using is trim. Sometimes text fields contain unnecessary spaces at the beginning or the end. Those spaces might not be visible, but they can cause problems when filtering data, grouping records, or comparing text values. By using trim, I'm making sure every review title and review comment is stored consistently. The next function is NULLIF, and this is one of those small SQL functions that can make a huge difference during data cleaning. Sometimes our customer doesn't actually write a review, they simply leave the text field empty. An empty string isn't the same as a null value. By combining trim with NULLIF, I can remove unnecessary spaces and convert empty strings into proper null values. This gives us a much cleaner dataset without changing what the customer actually did. Finally, I'll verify the clean table. The total number of reviews should remain exactly the same because we haven't deleted or added any records. The only thing we've changed is how missing text is represented. Instead of storing empty strings, the database now stores proper null values. This makes the data much more consistent and easier to work with during analysis. With that, we've completed the core cleaning process. Our data is now organized and ready for the next stage, exploring it to answer real business questions. Data cleaning is one of the most important steps in any analytics project. The quality of your insights depends on the quality of your data. I hope this walkthrough gave you a practical understanding of how analysts approach data cleaning in Postgres. If you found this helpful, consider subscribing because in the next video we'll start analyzing this clean dataset and uncovering real business insights using SQL. Thanks for watching and I'll see you in the next one.